Alright, next up here is a video on similar figures. These are just two-dimensional figures that we're going to talk about similarity with. And we mentioned the word similarity. What we're talking about is basically shapes that have figures that have the same shape but a different size. So for example, if we were to take this baseball field and maybe make it a little bit smaller, keep the same shape, but now it's maybe a little league field or something. So this might be a field for the major leagues, this might be a field for little league or softball or something. So we're talking things that retain their shape, but their sizes change, but they change in a very proportional way. And the key facts for similar figures are right here. Their corresponding angles are congruent. In other words, the angles that all sort of fit together and are on the same spot, they're all the same measure. Corresponding sides are proportional. We'll work with that. And the scale factor is defined as the ratio of corresponding sides. So we're just going to compare sides and we'll call that the scale factor. I'll probably abbreviate it as SF. Alright, so the scale factor is going to be really important in determining just how much bigger or smaller another shape is. So here we go. I'll do a bunch of examples here. Example number 1. Your first task is to find the scale factor between blue to red, or blue to orange rather. Alright, so here we go. To find scale factor, you basically just want to take a side that's corresponding to another side and divide them. So 114 over 75. Or if you prefer, you can also use the other sides. I mean, look at this. You can use 76 over 50 and get the same scale factor. Alright, in any event, you're going to get a ratio, a number that compares figure to figure. Alright, and that number is 38 over 25. And I just simplified that down by 3. Just divided both top and bottom by 3. Alright, so they're all similar, they're all equivalent to each other. I'm going to circle the middle one as my scale factor from blue to orange. And that ratio tells me just how much smaller the orange one is as compared to the blue one. Alright, we're going to use that to find missing sides in a little bit. Alright, big question here. Are these, this is number 2, are these similar? And that's the notation for similar. Maybe I'll write that down. Are these similar? And if so, what is the scale factor? To determine if two figures are similar, of course, you just want to compare their sides. So you pick sides that are corresponding. They're both in the same spot, upper left, and divide them. So I get 32 over 16. Well, that's 2 over 1. Alright, do the same thing for the other corresponding sides. 32 over 16, same thing. 41 over 20.5. 41 over 20.5. Well, that also happens to be 2 over 1. 45 over 22.5. Those are corresponding. Divide them, you get 2. And of course, same thing here. So our scale factor, well, first of all, these are similar. And our scale factor from yellow to green is 2 to 1. If I asked you what the scale factor was from green to yellow, you would say it's 1 to 2. Alright, so it just depends on what order you're looking for. But generally, I'm going to go from left to right. And the last thing that you want to do here is learn how to write a similarity statement. Similarity statement. And that's basically an order of letters. All right, so you want to say shape A, B, C, D, E, which is a pentagon, is similar to, and you want to start with the same corresponding letters. If we started with A In the yellow, we want to start with P in the green and go in the same clockwise order, P, Q, R, S, T. So all those letters should correspond with each other. And you should be able to just look at it and say, all right, I know that S and D are in the same spot. And turns out that, of course, they are. Number 3. Same question. It's a question of similarity. So here we go. We go 9 over 12. 9 over 12. They're both divisible by 3, so that's 3 over 4. And we go, the next set of corresponding sides will be 8 over 14. 8 over 14, they're both even, so that's 4 over 7. Oh, wait a minute. These fractions right here are not the same. Alright, so these figures are not similar. So sometimes you'll see that slash like that. They're not similar because their sides are not all in proportion. If they were, these fractions would all be equivalent. So you can really just stop after you get one pair that doesn't equal the first one that you found. Number 4. In this problem, we're saying that they are similar. You can see that right here. They are similar to each other. And the question, of course, is to find the value of x. X is right down here. Alright, so here we go. First thing you need to do is find your scale factor. To find your scale factor, just pick any two corresponding sides that are given. I'll pick 12 and 9. So we have 12 over 9. Both divisible by 3, so it's 4/3. That's our scale factor. That's going to unlock every other missing value for us. So now here's what I'm going to do. I'm going to say, all right, 4/3 is equal to 16 over x. So I'm using corresponding over corresponding. Alright, so this should be 12. Let's see, we're going to cross multiply. We solve proportions. Cross multiply, we get 4x equals 48. X is 12. Simple as that. Now you could have also used 8 and 6 as well to get your scale factor. Nothing wrong with that. Let's get the same thing. Number 5. Solve for x. So here we go. This word is important. They're telling us that the shapes or the figures have the same shape but different sizes. Their sides are in proportion. So what I'm going to do is I'm going to say, all right, the 16 doesn't correspond with a given value over here. So I'm not going to use it. I'm going to get rid of that thing. I don't really need to use that 16. But the 12 and the 8 will give me my scale factor. Divide them. They're both divisible by 4. So I get 3 over 2. That's my scale factor from large figure to small figure. This one's a little bit bigger than this one over here. So I go 3 over 2 is equal to 18 over 2x minus 2. And I cross multiply. When I cross multiply, I've got to make sure that I put this in parentheses. That's going to hopefully trigger a distributive property for you. 18 times 2 is 36. And a couple different ways you can do this here. You can distribute, or you can divide everything by 3 first. You get 12. And you get 2x is equal to 14. X is 7. X is 7. Right there. Let's check that. 2 times 7 minus 2. That's 14 minus 2. That's 12. So 18 over 12. Does that equal 12 over 8? And you can check it. 18 times 8 is 144. 12 times 12 is 144 as well. So that checks out nicely. Last one. Let's see here. We have a lot of different options here. First thing I might do is notice that this side corresponds with this side, so I'm going to need to use that a little bit later. And then I have 30 and 12, they correspond, so that's how I'm going to get my scale factor. 30 over 12, which is 15 over 6, which is, let's see, 5 over 2. And that's my scale factor right there. Scale factor from large to small. You could also write it 2 over 5, of course. So I'm going to use that now to unlock the x value. So if I'm going large to small, 5 to 2, so I need to start with my 40 and end with my -8 plus 2x. So I put this in parentheses and cross multiply. 5 -8 plus 2x in parentheses is equal to 80. Last time I divided by 5, this time maybe I'll distribute just to mix it up a little bit. I'm distributing that value, that 5 value, into here and here. And keep going here, we're almost done. I'm going to add 40 to both sides. 10x is equal to 120. X is 12. X is 12. And again, you can put that right here. You get -8 plus 2 times 12 is 24. -8 plus 24, that should be 16. So 40 over 16, does that equal 30 over 12? Well, if you cross multiply, you can confirm that everything is working nicely. You get 480 in the cross products there. So there you go. There was a 12-minute video on two-dimensional similarity. Next up we'll do three-dimensional similarity.